Good morning, I'm Brooks from Biomedical Engineering Department. And as part of our course in Material Science, we are to interview people with material science related projects. And as a matter of fact, we have Professor Adanu here with us. And in a brief moment, we ask him certain questions, very brief questions about himself and then his research work and then advice for students. So good morning. How for your time, even though you don't have time, you make time for us to meet with you. And as part of our questions, we would like to know something brief about yourself.
Okay, I went to Nordic school. I came to the University of Ghana. Then I went to the University of Bristol. Then from University of Bristol, I went to the University of Sussex in Brighton, England. And then I came back, and I've been lecturing.
Thank you for that. And can you please tell us something very brief about your research work, be it previous or currently?
I have had research work in materials. I worked on semiconducting compounds, talking about cadmium selenide. I have worked on diamonds, and I worked on manganese thin films. The interest in cadmium selenide was in relation to the fact that I got interested in solar energy research, specifically in the photovoltaic effect, in which we convert sunshine into electricity. Now, the primary material that was used for this used to be silicon. But as time went on, people used newer materials. Cadmium selenide is one of those that has been least worked upon. And so we thought it would be good to find out the characteristics of cadmium semiconductors. It is a compound semiconductor from the 2,5 group in the periodic table. So that's how I got into that. But before that, I had worked on diamonds. We want to find out the various types of diamonds that we have in the country. You know, we have a lot of diamonds in Ghana. That one, we were trying to look at their properties. We noticed that the presence of impurities in diamond played a very important role in the properties that they showed, the characteristics that they showed. So we did this work on diamond, essentially simply identifying the kind of impurities that are present in diamond, and therefore the uses to which the diamond can be put. Now, the interest that developed in manganese thin films was the fact that manganese has a very complex structure, crystallographic structure. Now, a lot of the properties that diamonds display occur at low temperatures, like liquid helium, liquid nitrogen temperatures. These are also explainable in terms of the impurities and imperfections that the manganese has. So those are the areas that I worked in materials.
Thank you very much for that. And from the way you spoke, it means your research work is highly related to material science. Were there certain challenges?
Oh, sure. There is a lot of challenges, like if you're going to make measurements at helium temperatures. Helium temperature is around 0 degrees Kelvin. So you have to think about what kind of materials to use to be able to reach those temperatures and also to be able to take your measurements. In many cases also the challenges have to do with the equipment availability. Now if you're going to determine the impurities present in diamond, for example, you've got to be able to find equipment that can take those measurements for you, and so on. So it's basically having equipment available, having technical people to be able to maintain the systems that you are using. For example, if you're going to be measuring things at near 0K temperature, then you've got to have somebody who can maintain the equipment so that it's working to those temperatures. Then of course there is a problem about actually measuring those temperatures. It's not like a simple case of dipping a mercury thermometer into the liquid. So there is the problems that come with the kind of project that you want to do.
Okay. So then the last thing we'd like to ask is that what advice do you have for science and applied science students, using yourself as an example in your work and your research?
Resilience. You just have to stick to it and try to do the best out of it. Now I think the choice of areas of research and study will be closely guided by what is going on in our country. In this country now, we have a lot of gold, we have a lot of diamond, we have a lot of bauxite, and so on. Now, science is not really useful if it's not transformed into a usable, practical thing. In other words, now I think people in the sciences must be gearing their efforts towards investigating the properties of these materials that we have. I'm thinking specifically about petroleum fund, which we have got in Ghana now. People should be working towards trying to exploit the petroleum we have, see the uses to which it can be put. We know that a lot of industries can spring out of petroleum products, and I think we should not overlook that in the choice of areas that we want to pursue our studies and our research. So those are the areas I would advise people to go into. It will not be easy, but we should be able to do that to benefit as much as we can out of the petroleum and the minerals and other minerals that we have in the country.
Thank you very much, Professor Danu, for your time you spent with us. We are very grateful for your time, and we do hope the next time we have such a program, we cooperate. Thank you very much.